Assalamu alaikum. So in this video we will be talking about data storage and you're watching CS by SS. Our today's objectives are we will be talking about computer memory, and then we will be talking about what are different types of computer memory we can use in computer. It consists on primary, secondary, registers and cache. Then we will be talking about what's the difference between primary and secondary memory. We will be having a brief discussion about cache memory. Then we will be discussing about types of primary and secondary memory in detail. So primary memory consists of two types, RAM and ROM. Then there are two more types of RAM, that's called SRAM and DRAM, and there are three more types of ROM, that's called EPROM, EEPROM, and EPROM. Right, and then there we will be talking about secondary storage devices, and secondary storage devices consist on three types: magnetics, solid state, and optical. Magnetics have two types: hard drives and tape drives, and solid state have three more types. And in same way there are two or three types of optical media. So we will be talking about these things in details in this video. So let's get started. First of all, what is computer memory? Computer memory is basically used to store data and instructions. आपको जो भी काम आप कंप्यूटर में करते हो, कोई भी इंस्ट्रक्शंस आप देते हो, आप प्रोग्राम ओपन करते हो, आप कोई फाइल ओपन करते हो, so whatever you are doing, you are using some memory. Okay, so what are those types of memory? It consists of four categories होती हैं आपके पास. It can be a CPU register, cache memory, primary and secondary memory. Primary memory also called main memory. Sometimes इसको हम volatile memory भी कहते हैं, which is directly accessible to the CPU. And secondary memory is called mass storage and non-volatile memory. And they can be represented in a form, like you can see. So it's just three types of memory: primary, secondary, and external. Primary की two more types हैं, RAM and ROM. RAM have three more types and RAM consist on two more types. ROM की तीन types हैं और RAM की two types हैं. First of all, primary memory and secondary memory. Primary memory is temporary memory. Secondary is the permanent. Primary memory is directly accessible by the CPU. See, and secondary memory does not directly accessible by the CPU. Primary memory consists of RAM and ROM, in which RAM is volatile memory and ROM is non-volatile memory. Volatile and non-volatile difference between that non-volatile is basically it will keep your data in it until the power supply is on. यानी जब तक उस मेमोरी को पावर सप्लाई मिलती रहेगी उसमें डेटा रहेगा, पर जैसे ही आप पावर सप्लाई बंद करोगे उसका डेटा बिल्कुल रिमूव हो जाएगा. तो ROM is non-volatile memory, but secondary is non-volatile memory. All types of secondary storage are naturally in non-volatile. Then primary memory is expensive, secondary memory is less expensive, and primary memory is basically used for primary memory used for semiconductor memories, but it is used for magnetic and optical memories. Primary memory also known as main memory or internal memory, secondary memory also known as external memory and auxiliary memory. And there are some types I have mentioned. So that's the big difference between primary and secondary memory. RAM. So first type of a primary memory is called RAM. RAM stands for random access memory. It is it is the part of operating system which is currently in use will be stored in RAM. जो भी आप instructions को solve कर रहे हो, आप कोई calculator use कर रहे हो, आप word पे काम कर रहे हो, all the instructions are used in or allocated in the RAM. Purpose of random access memory is to store data, instructions and software currently in use. यानी जो चीज़ आप अभी यूज कर रहे हो ना, सिर्फ उसको ही स्टोर करने के लिए रैम यूज किया जाता है. It is faster रीड एंड राइट हम कर सकते हैं, रैंडमली उसमें एक्सेस कर सकते हैं. इट्स अ वोलेटाइल मेमोरी. एंड द लार्जर द मेमोरी, डेफिनेटली जितनी आपकी लार्जर होगा रैम का साइज, उतनी अच्छी परफॉर्मेंस आपके सिस्टम की होगी. So usually we are using 4 to 8 GB RAM, but it's higher the RAM is, the more efficient your system will be. Then it's cache memory. Cache memory is a small size type of a volatile computer memory. ये भी एक volatile computer memory होती है जो provide करती है high speed data access to a processor. और ये उन systems को, उन softwares को use store करने के लिए use किया जाता है, which is frequently used. This is a temporary storage of memory. Cache makes data retrieving easier and more efficient. It is directly accessible to the system CPU. That's why it's the fastest memory in a computer and is typically integrated onto the motherboard. यानी ये motherboard के ऊपर लगी होती है and it's very fast because it's directly accessible to the CPU. Cache memory is frequently used to store application or the instructions or the data which is frequently used, जिसको हम बहुत ज़्यादा use करते हैं, ये उसके लिए use किया जाता है. It can be read and write better than the RAM. There are three different levels of cache: level 1 and level 2 and 3. Level 1 is situated within the CPU, but level 2 and 3 are situated on the motherboard, right? So definitely if you will increase the amount of cache, जितनी ज़्यादा आप कैशे का अमाउंट इंक्रीज करते जाओगे, उतनी आपकी परफॉर्मेंस सिस्टम की अच्छी होती जाएगी. एंड जितनी ज़्यादा कम कैशे मेमोरी होगी, उतना आपके सिस्टम को जो है उसकी परफॉर्मेंस कम हो जाएगी और डेटा जो है ना वो एफिशिएंट नहीं रहेगा. Okay, so cache is volatile, and volatile means whenever the power supply will be switched off, all the data will be removed or the lost. Next, there's a minor, not minor, but major difference between cache and RAM. Cache is smaller but fast memory. RAM is volatile memory. Both are volatile memory, RAM and cache. But cache is much faster than the RAM, and it's smaller in size, and RAM is greater in size, but cache is smaller in size. RAM is expensive, but cache is much expensive than the RAM, or both used to hold the program until the power supply is on. Both are its RAM is not compared to the fastest as compared to the cache, but RAM is faster than the secondary storage. And it can be, RAM can be internal and external, but cache will always be internal, right? There are two different types of RAM, SRAM and DRAM, but there are three types of cache: level 1, level 2, and level 3. RAM is short-term digital storage, which is used to keep a data and software that is not being used by the CPU, but the cache is located in close proximity to the CPU, or usually it's in on the motherboard. Next type of a memory, primary memory or the volatile memory, is ROM. So ROM stands for read only memory. It means we can just read the data from this memory, but we can't write it. So we usually have ROM contains the instructions which will be helpful for our computer boot up sequences. The boot up sequence is a set of instructions to the computer executes when the computer is initially switched on. It means जैसे कि जैसे ही हम लोग सिस्टम को ऑन करते हैं, तो जो फर्स्ट इंस्ट्रक्शन सिस्टम प्रोसेस करता है, it will always be saved in ROM. And this sequence will run a series of checks to ensure all of the system's hardware is working. It will then load the operating system. यानी जो बूटअप सिस्टम में सेटिंग्स होती हैं, वो सबसे पहले ये एक्सेस करता है कि ऑल द हार्डवेयर सिस्टम्स आर वर्किंग, मींस कीबोर्ड अच्छे से अटैच हुआ है, माउस अटैच्ड है, सीपीयू इज वर्किंग फाइन और नॉट. वंस दिस विल इंश्योर दैट एवरी हार्डवेयर सिस्टम इज वर्किंग फाइन, देन इज गोइंग टू लोड द operating system. Operating system is a software. So in the next video, we will be talking about what is operating system. So ROM is non-volatile, which means data will be stored when the computer is switched off. It will never ever remove the data. Whatever we will store inside this RAM, it will stay over there. ROM is read-only memory. It means we cannot write the ROM. So this is the hierarchical difference between the different memories. There we have a CPU. First, CPU can access data through cache, and then it can access data through the RAM, right? And after RAM will access the data through secondary storage, and this secondary storage will return to the RAM and cache and so on. There is a difference between RAM and ROM. The difference is that RAM stands for random access memory, ROM is read-only memory. RAM is a temporary memory, ROM is permanent memory. RAM is volatile, ROM non-volatile. In RAM, we can read and write data, but in ROM, we can just read data. RAM is used in normal operation, but in ROM is used for startup processes of computer. RAM writing data is faster, but in the ROM, writing data is slower. Then there are two further categories of SRAM and DRAM. SRAM stands for static random access memory. DRAM stands for dynamic random access memory. We have already discussed what are these memory. Now we are going to watch what is the difference between these two memories. SRAM constructed of circuits similar to D flip-flop. If you are interested in what are the flip-flops, do let me know in the comment section box. I will tell you what are the flip-flops. But currently we are not going in a very detail about flip-flops. So DRAMs constructed of tiny capacitors, छोटे छोटे capacitors होते हैं that leaks electricity. SRAM hold content as long as power is available, but DRAM requires a recharge every few milliseconds to maintain its data. SRAM is expensive, DRAM is inexpensive, SRAM is faster, DRAM is slower than DRAM, and SRAM cannot store many bits per chip because it's using flip-flops, and DRAM can store many bits per chip. SRAM uses more power, DRAM uses less power. Both use heat, but SRAM use more heat than the DRAM. And SRAM used for cache and DRAM used for main memory. Then there are three more categories of ROM: PROM, EPROM, and EEPROM. PROM stands for Programmable Read-Only Memory. EEPROM, Erasable Programmable Read-Only Memory. EEPROM, Electronically Erasable Programmable Read-Only Memory. In PROM, we can write program only once. यानी कि जो हमने एक दफ़ा लिख दिया उसके बाद हम उसको remove नहीं कर सकते. But in EPROM, we can erase the instruction through ultraviolet rays, but just once, maybe twice and thrice as well. But we take some money, or it's actually expensive to write information, and we need ultraviolet rays to remove the data. In double EPROM, information can be removed by electric signals. In PROM, the process of making program in PROM is called burning. Means just way के through whatever the process we are following to store instruction in the PROM is called burning. One of the example is CD. In EPROM, it's cheaper than PROM because it's reusable. Definitely, we can reuse this EPROM, so definitely it's going to be the cheaper. So that one example of this EPROM is ECD, erasable. EEPROM is used to store BIOS in memory, and its examples is CD, rewritable pen drives. So there is a question, and this question, one of the most famous question I have picked from the past papers. Take your 5 minutes and think about this question. I will be discussing about its answer in the end of my video. Next, we will be talking about what are the secondary storage devices. So we already saw the difference between primary and secondary storage. So secondary storage is not directly accessible by the CPU. It's used for permanent storage. It's non-volatile and it's needed as a primary secondary storage, and it can be read and write. The data accessing speed for a secondary storage is typically slower than the primary storage. It's often have a larger capacity, and it actually such as a software such as the operating system is saved permanently on secondary storage. The instructions and data that makes up the software that moves to RAM when it is in use. Secondary storage devices can be internal or external. So secondary storage जितनी भी हमारी hard drives होती हैं, or we can have a USBs, we can have memory cards, we can have all the hard drives जो कि हमारे system में भी hard drive होती है. These are all types of a secondary storage devices. We need secondary storage to process our system because we cannot store so much information on RAM and ROM. First of all, it's so expensive. Secondly, these most of those RAMs are volatile. It means whenever there will be power supply, everything will be removed. So there are different types of secondary storage devices. It may have solid state drives, USB sticks, SD cards, DVD, Blu-ray discs, CD, magnetic tape, magnetic hard drives, and many more. So I have categorized there are three types of secondary storage devices. The first one is magnetic. Magnetic consists of two parts, hard drives and tape drives. Solid state, we have two more parts, hard drives and memory sticks and flash memory cards. Optical, we have CDs, DVDs and Blu-rays. Magnetic drive. Magnetic hard disk drives have been the main part of internal secondary storage in personal computers for many years. However, solid state drives are increasingly popular due to their durability, low power consumption, and high read write speed. A magnetic hard disk is made up of several metal disks coated with a magnetic material. These are called platters, and platters are further categorized into different sections. Those sections are called tracks, and inside the tracks, there are different sectors, and inside the we can call some section is called tracks. So see, or basically magnetic drive look like this. We have multiple drives, multiple disks like this. One, two, three, four. There are multiple disks, and when we will join those disks, then we can get a one disk, right? So just look at this picture. In this picture, this whole disk is categorized in different tracks. Circle, goal, this circle. In circle, there are different tracks. Inside different tracks, this blue pink area is called sector. Inside this sector, there are different track sectors. Like whatever the sector we want to get, inside this B sector, this will be called track sector. And this is called cluster. Working of magnetic disk. Magnetic disk basically work like that. The hard drive spins the metal disk at a high speed, typically around 54 to 72 RPM using a motor. A read-write arm controlled by an actuator moves the head over the surface of the disk to the location of the data. The data is read or written using electromagnetics. Next is solid state. Solid state device is made up of different transistors that are arranged in a grid layout. It uses NAND and NOR gates. We will be talking about NAND and NOR gates in detail in chapter number maybe 9. Current flowing is 1, and when there is no current, then the value will be 0. In this way, we can convert our waves into digital data. A NAND gate will take in two inputs and produces an output as long as both inputs are not 1. A NOR gate will produce an output 1 only when both inputs are 0. So NAND gate and NOR gate both are going to use input A, input B, two inputs. But in NAND gates, we are going to get 1 until both of the inputs it have ones. Sorry, it cannot have both ones, right? And in the NOR gate, it's totally opposite. It means if I will get any one, I'm going to off. NOR is basically the opposite of OR, and NAND is the opposite of AND gate. Optical devices. So, optical devices work by shining a laser at the disk and processing the reflection. An arm moves to the laser across the surface of the disk in CDRs, or laser burns the data permanently to the disk by creating pits and lands. We will be talking about what is pits and lands in next slides, so have patience. So the laser is also used to read the data from the pits and lands. When the laser light hits the point where the pit changes into a land or vice versa, the light scattered and is not reflected back. This is captured by our sensors and can be interpreted as a change in the binary value. In CDRW, the chemical composition of disk is changed to represent 0 and 1. This change can be over. There are three different types of optical devices: CD, DVDs, and Blu-rays. Blu-rays have the largest capacity, CDs have the lowest capacity, but CDR are read only, CDRW are read and write only, and DVD-RW can be read and write. So all of the optical devices, or you can say the hardware devices, uses the concept of pit and land. Pit means we have something like that, and land means surface area. Whenever there is a pit, it means light is not going to reflect, so it's 0. And when there is a land, it's 1. So in this way, this is going to be read and converted to bits, converted our data into digital. Then I have just mentioned some difference between magnetic, solid, and optical disk. If we will talk about the cost, so highest cost is the solid state device, and highest capacity is magnetic. Durability is highest SSD, reliable portability and speed. Instead of just capacity is much better than in HDD. Otherwise, SSD is always and better than other these two devices, optical disk and HDD. Then virtual memory. The purpose of RAM is to store current data and program instructions in use. The amount of physical RAM available is limited. So the average modern desktop uses 4 GB and 16 GB RAM. So some programs are larger than this. Then we got the concept of virtual memory. Virtual memory is a part of the secondary storage which act as a RAM, but when RAM is full, it prevents the computer system crashing when RAM is full. So basically what happens, like virtual memory is nothing but it's just a part of a secondary storage devices, and it will act or comes in a action when RAM is full, right? So it will actually prevent a system from crashing. Data that needs to be accessed by the CPU directly is switched by the operating system from virtual memory into RAM, and an inactive page from RAM replaces it in virtual memory. This is called page switching. It means that if there is some data which is currently in RAM, but that data is inactive or we are not using their data right now, so it's going to be switch those data to the virtual memory. This concept is called page switching. So this happens. This is my secondary storage, and there is some portion which is virtual memory. And inside the RAM, there is some data which is not currently in used. So what it will system will do, CPU will switch transfer that pages to the virtual memory, and then whenever we will be needed those pages, it will be again transferred back to RAM. This concept is called page switching. So there are some steps I have mentioned. These steps will tell you whenever you are going to open any program in our systems, what steps are taken. So the first step is that the memory management software built into the operating system checks to see if there is sufficient space in RAM to move the new program instruction into RAM so that they can be directly accessible by the CPU. If the RAM is full, the memory manager will move out the most inactive pages of data and put them in virtual memory until needed, and the new program instructions are moved into the RAM. So if the RAM is not full, so then there is no problem. We are just going to move the instructions into the RAM. Cloud storage. So the cloud storage is a concept of storing data on remote server that can be accessed via the internet instead of a local storage devices such as SSD or HDD. The physical servers where the data is stored are owned and managed by a hosting company. Cloud storage warehouses often have thousands of servers containing hard drives. The hosting company provides services such as backing up the data, managing access to this data, as well as general security. This cloud data which is stored in the cloud can be accessed any type on any device as long as there is an internet connection. So internet connection is the limitation, otherwise it's very good. So the data accessible using a web browsers or a dedicated software that connects to the cloud storage. There is a potentially limitless storage, although it doesn't need to be paid for. Online storage means it is easy to share data and collaborate with others. If the internet connection is slow or lost, we cannot access our data. See, this happens. These are remote servers, right? And all the devices are connected to these remote servers, and we can access our data through any resource, through any server, through any device. There are a lot of benefits of cloud storage. The first one is accessibility, scalability, reliability, and security, right? It's really accessible. We can access from anywhere, from any device. We can increase or decrease the storage capacity in our system, and data is reliable. How it's reliable that we can store and back up our data. It reduces the risk of failuring the hardware device or anything else. We just have to protect our data through some passwords, but the security is the main concern, right? But we can apply two-way authentication. There is no need to hire a special force to protect your data. We just have to apply the strong password. Cloud storage have a lot of drawbacks as well. The first one is you do not need to purchase a local storage. We need to purchase more storage. It's expensive, and it's not environment. Although it's environment friendly, but sometimes we have to make sure that we have an internet connection or not. And sometime if we are short of money, then we have to pay the to buy the cloud storage. We may need to commit an annual subscription, and data being sent over the internet has the potential to be intercepted. There are high chances that if we didn't use the strong password, so data may be lost. So after this whole discussion, see, This is the pyramid of computer memory. Secondary is the lowest one, second main memory, cache, and CPU register. And access time will be decreased from bottom to up, but the cost per bit is increased. Means it's very costly to get a CPU register, but its access time is very low. Cache memory is also expensive than the main memory, but access time is small. Same goes with main memory and secondary memory. Secondary memory is cheaper, but it takes much access time than the other memory systems. I hope so far is clear about secondary memories, primary memory, cache memory, and CPU registers. We will be talking about CPU registers in more detail in our coming videos. So that's it for today. If you have any concern, questions, or problem, do let me know in the comment section box. I'll be more happy to answer your question. Thank you so much. So this is one of the exam style question. They can ask this type of question. Try to answer this question in the comment section box. And if you don't know how to do this, do let me know. This is the second question. Third question. Fifth question. Sixth question.